Okay.
Just practice run.
Alrighty.
So, are we ready?
Yep. No, we are live.
Okay. So we reviewed this issue previously, and as a summary, the issue was basically if you had, for example, armbase.arm64 as a nested class, but you didn't also have SHA-1.arm64 as a nested class, you could get into a weird scenario where SHA-1.is-supported would return false, but SHA-1.arm64 is supported would return true, because the SHA-1.arm64 would resolve down to armbase.arm64. We had, at the last review meeting, we had said we would expose the ARM64 class, we would give no inheritance, no is supported check, and we would mark it editor browsable never. However, this represents an issue for classes such as SSE3, where you have SSE2.x64, and you have SSE41.x64, but you don't currently have them on SSE3 and SSE3, which exist in between those in the hierarchy. And so in order for the rule to be consistent, when you've got that gap in the hierarchy, you really need to expose the x64 class with the inheritance and the proper is supported check at every level, even if they're not exposing any new instructions.
So the quiet is me thinking. So, do you have a particular proposal in mind or preference?
The proposal is rather than having them editor browsable never with no inheritance and no is supported, we just match the behavior that already exists, for example, with AVX2, which does have to have one because it exposes new members, where we have inheritance, we have an is supported check, and it's browsable.
But I mean, like we could do that, but the option of having the class that you can't do anything with in the middle tells you that you've written code that makes no sense. So do we want nonsense code to work, or do we want nonsense code to fail to compile and then you fix it to the code you meant?
It's already a case that you can write the same nonsense code today because, for example, since AVX, since
right,
AVX,
but we're fixing that.
No. There's you can't fix the thing that's already broken, in the sense that you can already today do, for example, AVX2 is supported, and if it's false, call AVX2.square root. And it will work at runtime because square root actually resolves down to the SSE method.
Right, and we can't stop that from working. We can't tell you there that you're using a feature that I have very mixed feelings about with the language of you're calling a static member off a derived type instead of off the type it's declared on. But if you're calling the is supported on a place that we don't have unique opcodes, then that's probably not what you meant. So I mean, like, we can certainly do either. I'm just curious why you're moving from make the compile fail to make the compile succeed, as if the same as if we hadn't defined it, but gives us a hook that we can put it in the future.
Because when we originally reviewed this, the only things we really looked at were essentially leaf classes, where they didn't have anything else inheriting from them. The issue comes in when you have, for example, SSE3, which doesn't expose any unique 64-bit instructions, but it exists between SSE2 and SSE4.1, which both do. Because then you get into a scenario where you can do SSE4.1.x64 and access the SSE2 x64 instructions, but you can't do the same for SSE3, even though previously you could, and it would work and work correctly.
Okay, so you're solving different weird problems, but making it more consistent.
Yes.
Okay. So seems reasonable. There's still a question of, while it's there just as a placeholder, EB never still seems reasonable, just to take it out of IntelliSense so that when you're writing, you don't really look for special ARM64 things once you've written SHA-1, for example. But if you want to say it provides no value there because if you were at a more derived type, they would show up anyway, then that's fine too.
Yeah, and that's basically the issue. Is what we originally decided on works great for if you have just a leaf class like SHA-1 with nothing else inheriting from it. But once you get into it's not a leaf class, you get into weird behavior with how it works and how people may already be using it in code.
So basically that means the general pattern that we then basically prescribe is, you would say, if you have an inheritance hierarchy, you have to also inherit all the nested types.
Right, which is what we've already been doing.
And so for SHA-1, the original proposal was we do that as well, and then we say we just say SHA-1 is supported. Why would we do that though?
No, so that's what the original proposal was, and I'm saying we just do the appropriate check for SHA-1 is supported, or for SHA-1 is supported, and we're on a 64-bit platform.
I see. Okay, that makes sense to me, because then we would also say if we ever have to add ARM64 specific SHA-1 instructions, then the check wouldn't change. Yeah, that makes sense to me. It's certainly also the most future-proof way of doing it. Yeah, I kind of agree with Jeremy. Like, we kind of try to be clever here, and that every time we do this, it ends up coming back.
Yeah. Yeah. I wonder if it would be valuable. Like, I know that there's the general problem of people being confused when they're calling static methods off of derived types. But I wonder if for the entire intrinsics type tree, if it's worth having an analyzer that is just like, no, don't do this. Like, you're going to add so much more confusion to your world than you want. Don't do this.
Well, I mean, for usability, we deliberately made that part of the design, though, right? Because the idea is, if you only care about, let's say, SSE3, you don't really care about supporting SSE2 and SSE1. With that warning, now I have to basically also consider SSE2 and SSE1 differently because I need to call them on the particular APIs, right? Versus with inheritance, you only check for SSE3 and then you call everything as SSE3 all the way down, right?
Fair. I mean, I don't know that we have an analyzer that's guarding the calls behind an is supported check, which would be the thing that would need to be taught about that. But
yeah, I mean, that was the idea, right? We said, like, if you call, basically you can call everything off of SSE3, assuming you check for SSE3 is supported, but SSE3 supported true implies that SSE2 supported also return true, and SSE1 also implied that it's true because of the inheritance hierarchy, right?
Fair enough.
So yeah, I mean, like, we don't have that, but I think that was why we went with inheritance in the first place. But otherwise, we wouldn't have done any inheritance. We would have just all defined them as individual static types, and I mean, that's what we tried originally. But that was a pain in the ass to write code in.
Fair enough.
But I agree with you. Like, it does tend to create these weirdnesses that we didn't really think through. But I think if we just say, okay, the nested types mirror that, it's probably not too bad. It just means also if we ever add a nested type to a type that is derived from, we may have to add the same type to like 12 other types, right? So I'm wondering if we should make our lives easier and actually write analyzers for ourselves to make sure that we make these things consistent. Because we will probably forget that.
Seems reasonable. But yeah, I think that if we're defining the is supported uniquely on all the 64 variants, that they should do the pointer size check, because if you specifically ask for the 64-bit version being supported and you're on a 32-bit processor, it feels like it should not say true.
Sorry, could you repeat that?
On the code snippet that's in the proposal, it says, the SHA-1.ARM64 is supported, is SHA-1 is supported, and then with an optional check of and int pitter size is 8. I think we should do the optional check so that on ARM32 it doesn't return true for ARM64.
Yes.
Right. It's non-optional because ARM64 is supported has to imply that base ARM64 is supported.
Right. Yeah, so really it seems like SHA-1.ARM64 is supported is SHA-1.is supported and base.is supported.
Right, effectively, which is, it won't actually be implemented as that. It will be implemented differently in the JIT, but that's effectively what it does.
Okay, so let me copy and paste the thing in that I have right now. Are we then in agreement with that?
Yeah, I assume that this is actually needing to go to something like 12 places already.
Yeah, it's going to be on basically anything that doesn't expose ARM64 or x64 today.
Right. Yeah. So maybe I should point this out here.
Seems reasonable.
God, typing on a different monitor is hard. So we need to, it's already approved, okay, so then let me just post this. And then I have to do something weird. Otherwise my notes will not pick it up. I need some sort of change in the status otherwise. All right, so here we go. Second one, store pair of SIMD and function pointer registers.
Can we take a look into the issue I sent in the chat?
As soon as I find this issue.
Do you want to give the summary of this one?
Sure. basically, when we approved this API for shift left and insert intrinsic, we decided to go with shift left logical and insert, and I believe shift right logical and insert. But for me, it doesn't make sense because those are neither logical nor arithmetic shifts, because the bits that got emptied by shifting to the right, they filled with the values from another operand. So I suggested just to name those the same way the underlying construction named, by shift left and insert and shift right and insert. And same for scalar.
I mean, if the logical or arithmetic is determined by another parameter, then I agree it shouldn't be in the name.
It's not that it's logical versus arithmetic here. In this case, it's essentially a logical right shift where the upper bits are then taken from another operand. So imagine if you right shifted by 2, the top 2 bits would become 0, and then you'd extract the top 2 bits from the other parameter and insert them there, whether they're 1 or 0.
Fair enough. So yeah, I mean, yeah. So if it's essentially just shifting across operands, then I mean, we could throw in the word across, but that I just made it up, so no one would understand it. If the thing is that this is not a simple shift, which could be described as logical or arithmetic, then removing that word and just saying it's shift left and insert, and you need to understand that it shifts from one operand into another, then that seems reasonable to me.
Yeah, and just for clarification, I sent a screenshot of the ARM manual in the chat.
Yeah, I don't have strong opinions, but it makes sense. I mean, like we try to be explicit with the naming convention. I mean, to me, and I'm not an expert in this, but to me, the overarching goal would be whatever makes sense for this ISA, right? Whatever naming we think makes the most sense. I would not try to align it across ISAs because we said many times that's, an attempt in futility anyway. So I would just shoot for consistency within that. And if you believe that the naming that Igor proposes does that, then I would go for that. Okay, one at a time, please, not everybody.
Yeah, I think it makes sense to drop the. If we have instructions that are, the whatever the element wise, like if it's an element wise right logical shift, where you pass in a vector and an int, like that one should have the word logical because that's what it's doing. But this one is complicated and it's neither logical nor arithmetic, so removing that word instead of inventing one makes sense to me. So yeah, it is just shift right and insert, and it's masking out all the bits that would have been arithmetic or logical, and then pulling them from another source. So it's neither of those. So don't use that in the name. Makes sense.
Alrighty then. So I guess that's the decision we're making. I have no way to record it easily here inside the question, but as long as Tanner and Igor are okay with that, then that's what it is.
Okay.
Yeah. So yeah, just to be for clarity, that's these shift and inserts where it's neither logical or arithmetic, makes sense to not have the term. But if it's not a complicated shift like this one, I do still think that the logical versus arithmetic provides clarity to the caller.
And we do add logical arithmetic for the ones that indeed logical arithmetic.
Okay,
Yeah.
so just making sure we're only talking about these and insert
Okay, I'll update
cross
this one.
vector ops. So cool.
Okay, and then I think we can move to store pair then.
Did we lose you, Emo?
No, I'm muted. So I like talking to myself, apparently. Yes, that makes sense to me. Turns out having a fancy mic does not protect you from being dumb. So should I record this somewhere, or do we just leave it as is because it's a bit weird in a question to respond?
I think we could just put it as a comment at the end of the comment chain here.
Oh boy.
I'm going to follow up anyway, so I'll update the names.
Okay, let me just...
Because I already merged the API.
Oh god, no, I lost the comment. Here we go. No, that's not the one. That is the one. All right. Okay, let me just hit R on this one. Let me just make my life slightly easier. All right. Then let's talk about SIMD and FP registers, which I assume which I assume means floating point, not function pointer.
So this is effectively just a set of APIs which stores a pair of vector 64 or vector 128 registers to the given address. It's supported for, I believe, all 10 primitive types. Igor, this one's not the meta question on related to tuples, correct? That's load, right?
Yes, it's about load. And
Okay.
I believe this one can be supported on ARM32 as well via STM abstraction.
And then the other note is there's non-temporal versions. Non-temporal meaning the same thing on x86 in that it does not go through the cache and it goes directly to memory.
Yeah, so first there's pair and scalar. What is the difference between the two?
So pair stores both registers sequentially, whereas pair scalar, and I made a comment that maybe it might be better named as scalar pair. It takes the lowest element from each vector and stores those sequentially. So rather than writing, for example, 256 bits, it writes two floats, where the two floats come from the element 0 of each vector given.
Gotcha.
So it's zip.
Yeah, for one element though. But yeah. That makes sense. I mean, yeah, whether you call it store pair scalar or store scalar pair probably wouldn't make a difference to me. I wouldn't be able to explain it either way. What does the
Yeah,
underlying
I
instruction call it? Because
agree.
the names, what does STP stand for there? Store?
Probably
Store
store pair.
Oh, store pair, I guess. Yeah, okay, fair enough. Yeah, I guess either one is weird.
Yeah, either scalar pair or pair scalar, whichever one you feel happier about.
I don't have a strong preference. I just like how store scalar pair sounds over store pair scalar.
Yeah, I mean, I guess it's if everything that is a scalar version of the vector thing has scalar as a suffix, then
Not all of them do, just most of them.
okay. I was gonna say if this is gonna be the first infix one, then you need to feel really happy about it. If we're already all over the place, then whatever.
There's a few like comparisons where we've reordered scalar because it made it more clear as to what the operation was doing.
Well, let me just copy this. And then I will
What's temporal mean? Or temporal, or however they feel like pronouncing it.
Non-temporal means that it writes directly to memory. It does not go through the cache.
Right, the point of the name means that it's non-temporal and that I don't expect to use this soon. So non-timely.
Oh,
Fair enough.
I see.
The main use case for it is you're writing large amounts of memory such that you're going to blow the cache over and over, in which case avoiding writing to the cache actually causes performance to increase.
Gotcha. So normally it will commit it to both the cache and the actual memory, right? And this will
Right.
just commit it to memory. Yeah, I don't have.
And I
strong
assume
opinions.
those are spec words.
So what's a spec word?
Temporal.
The non-temporal.
That's a spec word, and it's the same one used by x86.
All right, good enough.
Yeah. Why do we have more non-temporal ones than we have anything else? Are there more overloads? Or is it just, no, I guess it's the same as store byte, right? Yeah. So you want to swap scalar and pair, right?
That was my suggestion, but if I don't feel particularly strongly, so if Carol or Igor or Bruce or anyone else has an opinion, I'm happy to use either.
Will it be harder to find the scalar pairs if they're not postfix?
So the way
Not
IntelliSense
with
works
modern
now,
IntelliSense.
yeah, like it doesn't do like partial matching, right? So if you type store scalar, it will no longer show you store pair. But if you say store pair, it will show you both store pair and store pair scalar, right? Because it's a prefix thing. And if you just type scalar, it will also show you store pair scalar, right? So it makes postfix, infix, and suffix matches, but it will not, take the words apart and then do partial matching or something, right? So I think it's fine. I think either way will not make IntelliSense harder. The only thing to consider is this general sorting, right? When you go to the docs pages, if you say, store pair scalar, it will basically come directly after store pair. If you say store scalar pair, then, well, wherever the fuck it sorts, right?
So, also the architecture manual doesn't use the term store scalar pair or store pair scalar anywhere, right? That's something we've made up.
Yes, because we need to somehow describe that we only storing the lower part of 64-bit registers, because store pair instruction can operate on 32-bit or 64-bit registers.
Well, and it's the instruction manual does use the term scalar, but it's generally a parenthesized postfix. So, for example, it will be store pair parenthesis scalar close parenthesis, or shift right and insert by element in parentheses. Also, IMO, just as a note, modern IntelliSense does separate the words and show both scalar pair and pair scalar if you type store scalar.
Really?
Yes, I think that was introduced with the IntelliCode changes.
Holy shit. Yeah, I guess I'm not using VS these days enough. I stand corrected then. I mean, to me, the sorting is still one thing to consider, though, because you know,
Right.
sorting is still something people, as they explore IntelliSense or if they read the docs, right? So, like, you generally want to make sure that things sort in a somewhat sane way, but I think either way here is fine, because they're all, like, store related, so. So, unless I hear strong thing, I will just leave it as is because it's easier for me.
Sounds good.
Um, dun, 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 dun. Cool, then I think we are almost done. So then, talked about the non-temporal ones. Okay, so that's fully done then.
It's same list. But should it be store non-temporal pair or store pair non-temporal either?
Yeah, I mean, before we said we want to have it in all in operations, right? To me, it seems like it's kind of sensible to have the non-temporal as the very last thing because it basically just controls whether you write it to the cache or not. And the first one is basically more talking about how you retrieve or store information, right? So it seems more important than whether you hit the cache or not. So I would not put scalar at the end.
The instruction manual for it even has it as a postfix. It's store pair of SIMD&FP registers, comma, with non-temporal hint. So they buried it as a suffix in their guide, but an infix in their assembly language. So obviously they had the same debate and decided to go both ways.
Or
yeah,
they just didn't talk to each other.
Yeah. So yeah, if I'd say infix or suffix, whichever one we've done for existing instructions, I assume it was a suffix, and so what Emo pasted.
Yeah, again, I don't have strong opinions. It's just that, you know, consistency with what we decided previously, it makes to me more sense to make it as a suffix. And
right.
Keep the scalar before that.
But now, if you look in the documentation and sort them by this name, then store pair scalar will come after store pair non-temporal.
That is true. I mean, like that is the downside. But I guess that's kind of like it depends on how you want to reason about the instructions, right? Because there's multiple ways you can organize them, right? Whether they hit the cache or not, whether they are scalars or non-scalars, and so like you just have to pick one thing because you can't make all things work, right? And I guess when you write code, it makes more sense to me that the very first thing you're looking for is basically how the instruction is actually writing information to the memory. That's probably more important than whether it hits the cache or not, because if you don't find an instruction that writes it out in the layout that you want, then whether it hits the cache or not is not actually that relevant anymore.
I also think with the way the docs group method overloads, it's not going to be too big of a concern, because it's not like you're going to have to scroll through 20 to find store pair and then store pair non-temporal. It will just be, you know, store pair, which links to the group of 10, and then store pair non-temporal, which links to the group of 10. So they'll be relatively localized and together.
Yeah. Alrighty, then let's move on to the next one.
Just a few doubling multiply intrinsics that were missed in a previous review. It's the same name ordering that we have for the other ones. So doubling multiply saturate high, doubling multiply by selected scalar saturate high, doubling multiply saturate high scalar, and then I've got a to-do note there for doubling multiply by selected scalar saturated high scalar. Namely because I wasn't too sure about the names, but it's the same general convention as the above.
I just want to add that I don't think we have any doubling intrinsics yet in the API. Those are the only ones.
Okay.
And also for halving operation, the operation that takes a half of the result, we used add halving or subtract halving. And last time I suggested to swap the order and use multiply doubling instead of doubling multiply.
That makes sense to me.
And also for halving, we used fused prefix. And technically speaking, those are also fused. And I'm wondering if we need to add the prefix here.
Yeah, we should for consistency, I think.
So what was the first thing you just said? What do you want to swap?
Multiply and doubling.
So you would say multiply, doubling, saturate high?
Yeah. Or fused multiply doubling, saturate high.
So that it sorts with the multiply and fused multiply?
So, sorry, can I say it again?
Is that so that it sorts with multiply and fused multiply? Or just because it seems like multiplies the verb or what?
Yeah, so multiply is verb and doubling is basically description of how we do multiply. We did already same pattern for add halving.
Okay. Yeah, if we already have a pattern, then we should follow the pattern.
Or we can change the pattern and just drop fused and like swap halving and add in the instructions that we already implemented. Just
I think the fused is important because it qualifies that you are getting a full result. So if you do FF plus 1, for example, you're going to get 100 as an intermediate. That's going to be used as part of the next computation, which is the doubling, rather than, say, overflowing to 0 and doubling back to 0.
Yeah, but I checked the manual and never said fused for either halving or doubling instructions. So
right, but in a past review around the multiply add, we determined we should prefix with fused to help clarify the overflow behavior.
I think saturate already kind of said that.
Well, the difference here is it does a non-saturated multiply, a non-saturated doubling, then it adds, and then it saturates. Sorry, it takes the high half, then adds, then saturates. So the add is the thing that does the saturation.
I mean, that makes sense to me.
And for rounded one, how are we going to name them? Fused, multiplied, doubling, rounded. To be consistent with fused, add, rounded, halving.
Yes, I think so.
Rounded should go before doubling.
So the rounding, I guess. Okay, here's what I will do. I will just copy and paste the stuff over to the text box and we can review it there. Because I think the way it's written here is not very amendable for easy overview.
Yeah, I'm reading the manual. I can't tell when the rounding occurs.
At the right time.
You have to scroll down to the
Well, in usage it says the results are rounded, but this instruction multiplies the values of corresponding elements of the two source SIMD&FP registers, comma, doubles the results, comma, places yada yada yada. Then the results are rounded. So was the results of the multiply or was the result of the double?
The result of multiply doubling is rounded.
Yeah, you have to scroll down to the operation for all encodings part, which shows that it's 2 times element 1 times element 2 plus round const is a intermediate product that is more precise than the inputs. And then you take the upper half of that and do a sign saturation.
So the rounding is after the doubling.
Yes.
Well, in the same time with if it's multiply add or multiply subtract, it happens in the same or in the same how to say precedence. Basically, you add doubling product with surrounding constant and the addend or minuend, and then take the upper half and sign it, and saturate it. I guess it's easy to send a picture.
I'm just making sure we're consistent. We're putting the words in the order that you would observe the side effects with parentheses. So,
yeah, that's what we said we want to do.
Just send a picture.
And apparently you're looking at a better version of the manual than I am, Tanner, because I don't have one with a formula in it.
You have to scroll pretty far down to find it.
No, I'm at, I've hit the bottom of a page. It's a pretty...
That's because it's on the second page. But yeah, so the rounding is effectively part of the doubling operation. It's basically you double and then you add the round constant. So I think rounded doubling makes sense. And I think that's what Igor suggested.
Mm-hmm.
Okay. Because it's describing the doubling instead of... Sure. Okay.
So to summarize, it's going to be fused, multiplied, doubling, fused, multiply, rounded, doubling.
Yes.
Okay.
So I'll be there in a sec. So I need to. I'm almost done with aligning the parameters. All right. Let me paste this guy in here. Is this the right one here? Well, yeah, that is the right one. So we said multiply doubling. And then what did we say about the rounding? Where does the rounding go?
Multiply rounded doubling.
Multiply. Okay, multiply rounded doubling. And let me swap multiply and doubling again.
So for widening, I have a question. Should lower go as the last part of the method name, or it should be after widening? It's going to be multiply, doubling, widening, lower saturate, or multiply, doubling, widening, saturate, lower. Because I guess in the past we used lower only the last part of the method name. I never had them in between the words.
Could you type out the two names?
Sure.
Yeah, I'm sympathetic. I cannot keep a sequence that long in my head. By the time you spoke it out, I forgot how you started it.
Yeah, just sent. I forgot to add use prefixes. It's fine.
The widening, so it does 2 times element 1 times element 2 and saturates the widened result. So it widens and then saturates.
Yes. But the question is if lower should be the last one in the name. And given that we already add them only at the end, probably should be the last one. Otherwise, we'll break our own pattern.
Yeah, I think that makes sense.
Because basically, lower set where you're getting your operands, either from the lowest half or the upper one. And it probably should be closer to the actual operand, like to the parentheses, I mean.
So then we are going with multiply, doubling, widening, saturate, lower.
Mhm.
All right, so then let me...
And it should be fused, multiplied, double.
A la mode. It obviously just needed more words.
It's worth noting that for in between the two groups that were just talked about, there's the fused operations. The fused operations in particular aren't 8.1 or 8.0, and so they can't be on the advanced SIMD class. They're actually 8.1 and required by an 8.1 implementation. The official flag bit is just called RDM.
You're talking about saturate, round, multiply, add, and multiply, subtract.
Yeah.
Yeah, they should be under 8.1.
So based on our conventions so far, it would be under a new class called Public Abstract Class RDM, which inherits from Advanced SIMD.
But are you going to implement them now, like in .NET 5?
They, like dot product, would be a if we happen to have time.
So how many instructions in this are the RDM extension? Like if it's just those two, that shouldn't be a problem.
Yeah, it's just SQRD, ML, AH, and SH for by element and by vector.
Okay, so just for different intrinsics. Okay.
I mean, some of the method names do sound a bit like a Monty Python sketch, I have to say. Multiply, doubling, subtract, widening, lower by selected scalar, saturate. That's quite a description. Yeah, I think you can... I mean, we don't have to do all the instructions yet, right? We can still add nested types later, right?
Right. Well, in this case, it wouldn't be a nested class. It would be a new top-level class called RDM.
Oh, I see. I see. Okay, fair enough. And
you're saying it's not going to be derived from advanced SIMD?
Yeah, in the same way that SSE2 derives from SSE.
So does this affect any of the existing methods here, or is this something that you just saw as a news?
No, it impacts two groups of methods in here. So specifically the fused methods. So
they're all fused.
No, they're only fused when sorry, I mean fused as in also doing the addition. So the and accumulate, or multiply add rather, and multiply subtract.
Well, I think it only applies to rounded, multiply add, rounded, multiply subtract, because the one that does not do any rounding, they belong to advanced SIMD.
Yeah, you're right.
Sorry, I think you lost me. So the one that have add in the name, so for example, multiply, rounded, doubling, add, saturated, high, are those the one that you would put in there?
The ones that are both rounded and add or rounded and subtract.
Yeah.
Right. So this is. I see. Okay, I think I got it. So this is like. Basically line 42 to 78, which probably doesn't help you because you don't have line numbers, but yeah. And the top level type will be called RDM.
Yep. As that's the official flag bit that they use.
Okay, hold on. Public abstract class RDM. Would it inherit from advanced SIMD?
Yep.
All right.
But how do you find this flag? Because what I see is it just checks for ARM v8.1 extension.
If you look at the architectural features added by ARM v8.1, it lists the, and I'll just screenshot it for convenience. It lists the actual CPU ID bit that it checks.
So it's a separate bit for these particular instructions. So it's
Right,
not going to be
because-
just we check 8.1 and we're done.
Well, there's an explicit bit, but as it states, it's mandatory for v8.1.
And you think RDM stands here for the ISIMD?
That's the flag name. It stands for rounded double multiply.
Hmm. Since it says the feature is mandatory in 8.1, but it still can be implemented in just version 8, right? And we need to check for RDM flag instead of checking for 8.1.
Right. We've said that we explicitly check the flag even when a feature is mandatory. For example, SSE and SSE2 are mandatory for 64-bit x86 CPUs, but we still explicitly check and expose them under the corresponding flag name.
Mm-hmm. Because in my manual, the feature called RDMA, I can send you my screenshot. Even though the flag still says RDM. Shall we name the class RDMA instead? I just can send the whole picture.
I'd imagine that's just a typo there.
There, where? Like in my version or in your version?
Yeah, that it says RDMA. Because if you actually click on the link and go to the ID AA64 ISA R0 EL1 register, it shows RDM there as well.
Okay, let's just Google it. Well, the website also said RDMA for the feature.
I think that's their public name for it.
Okay.
But the CPU flag is still RDM, which is what we've gone with for everything else so far.
Yeah,
is
but
going with the CPU flag name to avoid ambiguities between things like, for example, something being called Neon in their marketing name, but using some different moniker, such as Advanced SIMD internally in their CPU ID bits.
yeah, Neon, I guess, name for ARM32, not even the same for ARM64. Okay, so I'm fine with both, but I'm just wondering why it says RDM.
I think it's the same for dot product. For example, the official name is dot prod, but the official CPU ID bit is called DP.
Yeah, but for example, GCC compiler, they use they different they have different identifiers for all these IC extensions, and for RDMA they use like RDMA and not RDM. Yeah, send the link.
So what does it mean? Where will ending with the name then?
My preference is for RDM because it matches what the CPU register uses.
I mean, the question is that something I can look up and find a hit, or is this something I have to like dig for half an hour?
Well, if you Google RDMA, as I did right now, so you'll find multiple pages.
Well, that's the other problem though. Like, I mean, do I find too much? It's like basically when I search for RDM or whatever you just said, I couldn't quite hear it. Like, how specific is it? Like, is it relevant to this? Like, I mean, SSE2, for example, very clearly relevant, right? Versus this one seems more like you kind of have to read the fine print, as far as I understand what Tanner said.
Well, if you search for, you get relevant hits for if you search RDM or RDMA.
Okay.
And it honestly also depends on which version of the menu you're looking at. If I look at several versions across 3 years here, I get different results for RDM versus 8.1-SIMD versus RDMA.
Yeah, I would just go with whatever the latest one is, because that's clearly the name that they are going
Well,
with.
the CPU bit is the thing that's consistent across all of them.
I see.
It's always RDM as the CPU bit, which is what I was saying earlier on. They might have a marketing name like Neon or something like that. But if we match the CPU ID flag, then we won't have an ambiguity.
Yeah, I can get behind that. I mean, marketing does change its name, its mind, and then the name. So yeah, let's go with RDM then. It seems like the most reasonable thing. Unless somebody has super strong objections to that. Going, gone. All right. So did we skip anything, or is that all we have?
I think that's everything for that issue now.
So And the one overload that takes write and byte index, is that named the way we usually name them? Didn't we usually have a selected index somewhere in the name?
No, we used write index to clarify which one it was coming from.
Cool. Then I guess, hold on. Almost done. All right, then this is the one we have. I have to edit this guy again. Almost readable now. All right, the to-do markers, I assume, is something you want to submit later.
Which ones?
You have these to-do markers you have in here.
Those ones I called out at the beginning, they're essentially the same as the by selected scalar. It's just they're by selected scalar against a scalar.
You know what I'm asking is, like, are you submitting them later as a separate issue, or what is the plan with those?
I guess there is need to submit them. I can just implement. So I see the pattern we used in previous similar methods. I can just repeat this pattern here.
Yeah, I can go either way.
They should be implemented as part of the complete work for .NET 5. And so if we can just say that the name is consistent, then we can just implement them.
Yeah, that works for me. Let me just call this out. All right. Cool, then this is it for this one here.
Yes.
And let me close tabs so we keep track of what we have done.
Okay, so the first ones here are ones that are need just a little bit of discussion and context. These ones are essentially the counterparts to store pair. However, given that it's returning a pair of vectors, we obviously can't. We have to return it all at once. Whereas with store, we can of course just pass them in as multiple separate parameters. For this, we opted to use a value tuple. We didn't come up with names, as I'm not necessarily sure there are good names for them, other than necessarily item 1, item 2, value 1, value 2. It's a value tuple because we don't think we need a strongly typed struct to contain them, although we could potentially create one. And I believe Carol has recently done work in the JIT to make multi-register returns work nicely with this particular pattern.
Right. I'm still working on arguments, but the returns are doing pretty well.
Well, that's half the work.
One thing, at some point we need to discuss load multiple consecutive vector 64 or vector 128, and shall we defer the talk about load pair till the later point? Meaning, like, shall we push out load vector 64 in case we find some nice solution for load multiple vector 64 in the future, so we can just use same structure for the returning value here and there. So one of the proposals could be vector 64x2, which basically is pair of vector 64, or vector 128x2.
I think that largely depends on whether Carol thinks that the case of sequential registers will need a special type versus being able to just make it work with tuples.
So I think that the right way to do it, the easiest way for the JIT to support it is tuples. There'll be tuples with a special requirement that, it's going to take some work to get it to be supported. But from the perspective of the rest of the JIT, the front end to the register allocator, the tuple is the right way to go, I believe.
So even for multiple consecutive registers.
Right. I mean, this is sort of, I believe the right way to support it is it's sort of conceptually the same. It returns multiple registers. It requires multiple registers. This is just an extra wrinkle that the register allocator has to ensure that they're consecutive. And when I say just, I I mean, and it's a lot of work for the register allocator.
Yeah.
To clarify for everyone else, so load pair loads a pair of loads 2 vectors from the given address, and it returns it in 2 registers. But those registers can be essentially any register. There's other variants of load, which we're not doing for .NET 5, which likewise can load load 2 vectors from an address, but they are returned in 2 sequential registers. So register 1 followed by register 2, or register 2 followed by register 3. They can't be arbitrary registers. And in that case, it supports up to multiple.
Up to 4.
And so it sounds like tuples are the right way to go. It's just going to, no matter what we do, it will just be working the register allocator to make happen. Sorry, Carol.
Yeah. So just to clarify, in the current state, it's easier for the JIT to support it as a tuple because it doesn't have to manufacture a type out of thin air. If there's some reason that an API using tuples would be considerably less desirable, that's something that's something the JIT can do is construct a fake, a fake tuple. But it would be more streamlined if it were already a known struct type.
I'm just curious. Does it mean that if we use tuples for values of 2 registers, when we load, we don't have to go into the memory, into the stack? It can stay in registers and be in registers full time while we're working with these values.
Yes. So I actually have a draft PR that adds a register, a 2 register multiply on x86. There's some issues with it, and it's kind of at the bottom of my to-do list right now because there's other high priority things. But there's definitely a proof of concept that it can be done, and you can actually generate code that doesn't put it on the stack.
Yeah, I think tuple's good for pair, and it sounds like we'll need something more complicated when we want to deal with multiple.
All right, then if no one has any other comments about the load pair, I think we can move on to the next ones, which are just below that.
And so for load pair scalar, we keep the order, right? So we say load pair scalar, the same way we said store pair scalar.
Right.
And suffixes get to 64.
I guess when I say that tuple seems good, I'll just confirm that you expect that the 99% case is someone's just going to use deconstruction to assign it to two distinct locals. They won't care about the tuple, right?
That's my expectation.
Yeah. That's what I expected based on the API, but just making sure. So I'm good with tuple.
Does anyone have a preference on the name? Just leaving them default, which would be item 1, item 2, naming them value 1, value 2, or naming them lower, upper?
I don't see what we're talking about. Oh, for the named tuples?
Yeah.
I mean, if lower and upper are names from the spec, that sounds good.
They're not names from the spec. They just roughly match the concept of lower and upper that we use elsewhere.
Yeah.
I think it might create confusion because we use lower to describe the lower part of the register, not the whole register.
While the guidelines say, name all your tuples, in this case, I don't think that there's any name we can add that helps, right? It's this was the first one, this was the second one. They don't have semantic meaning. They're just this one's first and this one's second. So the default names are fine.
If we wanted consistency with store pair, they would be value 1, value 2, which is what we named the parameters for store pair.
All right, sounds great.
So what did we do for link, by the way? Does anybody remember? I think because it's the same thing with zip, I think we also said, well, the best name is item 1, item 2, right?
Well, zip, we named it
first
and second, because that was the names of the parameters you pass into zip. So
I guess that makes sense. Yeah, in this case.
Yeah, so yeah, I agree with Tanner's most recent statement. If we named them value 1 and value 2 in store, then we should call them value 1 and value 2 in load.
So basically you're saying that we should have value 1 and value 2.
Your V's are capital, right?
I mean, of course.
Just making sure. We didn't spend 10 hours in that meeting for nothing.
People still hate us for that, just so you know. And it's definitely item 1, item 2, not like item 0 and item 1 or something like this.
Default names are item 1, item 2.
Because that would be extremely bad if we just, because the item 1, item 2 names are also available if they're 1 based and the one is 0 based. Or the other way around.
Value tuple of T1 and T2 has item 1 and item 2.
Okay. So did we change anything else or just the tuples?
Everything else was the same, just adding in the names.
Okay, and let me comment on this.
And then after the load pairs, there's we hadn't finished reviewing the last half of the proposal MO.
Yeah, that's fine. I mean,
Okay.
The problem is just if I paste a comment, it has to be within 15 minutes of me approving it, otherwise the tool doesn't pick it up. So,
Okay.
But we will approve it, right? Like, we're not going to reject it.
Yeah. The next ones are extract, narrowing, saturate, lower, and upper. These all take in a type and return the same type. And then there's extract, narrowing, saturate, unsigned, lower, which takes in a signed type and returns an unsigned type.
And I commented below, I believe extract, narrowing, saturate, unsigned should correspond to SQXTUN instruction. Probably typo in the proposal.
Which one, sorry?
The extract, narrowing, saturate, unsigned, from what I read in the doc, should correspond to SQXTUN. So basically signed saturation to unsigned type.
Yeah, I might have those mixed up by accident.
Mm-hmm.
So what should they be instead?
Just instruction correspondence. I guess it's not that important.
Oh, I see.
Yeah, it's just the comment above the SQXTUN and UX or UQXTN. The comment should be swapped.
Yeah, I just leave
But
it from the
that's
review anyway. So yeah. So, yeah, is there anything we need to change? Or are we happy with the name then?
I mean, if I look at the names of these and my eyes gloss over, so if
Well, but that's true for all the hardware intrinsics, right? I'm sure that's a...
no, I can totally understand what reverse element bytes means. I can parse that sentence.
But can you explain what it does? And would you be correct?
It changes within each element. It changes little endian to big endian, or vice versa.
Yeah, so moving on to reverse element bytes. Yes, that's what it does.
Good name.
So the interesting part is the comments at the bottom. So Rev 16 naturally takes in short, and short, and it swaps the bytes on those. Likewise, Rev 32 will take in a 32-bit element and swap the bytes on that. However, there's also a variant that swaps each 16-bit portion instead of each byte. I have no clue what to call that.
Well, reverse element U-shorts.
We can't call it U-short. It would have to be uint 16 maybe.
Sure.
And then likewise for Rev 64, there's bytes, uint 16s, and uint 32s then.
Yeah, using the pool is a bit weird in that context. I mean, you could, but yeah, I guess that's the best.
Using what in that context? Sorry.
So, yeah, using a plural name there is a bit weird. Like, you know, UN 16s seems a bit weird, but I guess.
Right. That's the, like, bytes is very obvious what it's doing, but if you call it UN 16s and you're passing in a U long, it's kind of confusing.
Yeah,
But
you could also
UN 16.
you could also maybe just make the method name slightly longer, right? Or instead of saying reverse element bytes, we could say reverse element by byte, and then, you know, reverse element by UN 16.
Can we call them half word and double word?
No, because the what word means is very contextual based on a lot of scenarios. Like ARM might refer to a half word as 16-bit, but on Windows, word is very clearly 16-bit, not 32-bit.
I mean, what
a
about
half word is actually a byte on Windows?
what about just using the bit count? So instead of saying, you know, uint 16s, it's just like, you know, reverse element 8, reverse element 16.
I can live with that.
Yeah, that's not terrible. It's not amazing, but given some of the other names, it's also not the worst API we'd be exposing.
Yeah, I think you're lowering your bar now, but my favorite API of all times is still WebSocket is application targeting 4.5. As long as we don't build that, I'm happy. Yeah, should we add them already, or is this just future-proofing at this point?
No, these are ones that are part of the .NET 5 work. And we actually have explicit use cases for them. For example, with system bit something or other reverse bytes or whatever.
No, I'm not talking about the bytes one. I'm talking about the 16 versions.
Those are also part of the same. I just didn't have good name suggestions for them.
I see. So basically, I would just copy paste and so basically what we said is reverse element 8, right? And then we would just copy paste it in and we'd have reverse element 16.
Right.
Yep, that works for me. I
guess we also need a non-advanced SIMD version, because there's a ref16, ref32, and ref64 instructions that operate on general purpose registers.
So for those ones, since they're baseline instructions and since they're essentially core instructions, it was determined that we didn't need to expose them as explicit intrinsics. Instead, we would just tell users, just go use now I can't remember the name of the API.
Bit converter?
Yeah, I think that's the one.
But what about reverse element bits? We already exposed them. RBit instruction on general purpose registers.
Right. That's because RBit doesn't have a corresponding, essentially baseline equivalent, where it's available on all platforms and things like that.
They're saying that for anything else, we already have corresponding bit converter method. We just need to expose only reverse element bits, and all other functionality can be achieved via bit converter.
Right.
Okay.
There was a pretty lengthy discussion on some of the issues between Jan and I, where I originally suggested we should just expose the intrinsics anyways, and he pushed back strongly on we don't really need to do that, and I finally caved in.
I assume there's no reverse element 16 for the short types?
Right. Because that would be a no-op.
Right. I was trying to figure out your spacing, especially once Emo copy and pasted it. So I think it's that you had them in the 16, 32, and 64-bit chunks. And so when we get to reverse element 16, we don't need the 16 bits. And then is there a reverse element 32?
Yes, for long and U long.
So what did I fuck up?
All right, so you have 3 reverse element 8 blocks.
Yes.
That's good. Now delete the first reverse element 16 because you're saying reverse 16-bit values 16-bit-ly, which makes no sense.
Oh, I see. Okay.
And then copy the last reverse element 16 and paste it and make it reverse element 32.
Gotcha.
So 3 8s, 2 16s, and 1 32.
Yep, that makes sense. Alrighty, then this is it?
That's that one. And then there's just 2 issues left.
I think this one we
that one
right?
that one should be 38137.
Sorry, 3. So this is this one here, right? That's the one we haven't done yet.
No, there's one other we've not done yet that you don't seem to have open. It's 38137. Which is a really small one. Basically, we just missed the InsertScalar variants that took double long and U long.
Seems fine to me. Unless somebody...
I mean, if this is just an overload that we missed a generic argument, then it seems fine.
Yep.
And I get the class name should be advanced SIMD, not advanced SIMD ARM64, because below Tamar suggested how it can be implemented on ARM32.
Have you generally been doing software fallbacks?
Well, seldom the software fallback, it will be a particular instruction.
Okay.
This is just a case where it can be implemented with a single instruction on ARM32, but the C++ intrinsics don't expose it like that because they don't have a vectors, or they don't have a double X1 type for ARM32, and so it was missed in the initial proposal.
Okay. So put it in the class it belongs in.
Yeah.
Okay, so what does it mean then? We put it out into advanced SIMD, or does it mean we put it in both ARM64 and ARM32?
Just advanced SIMD.
Just the last one, or?
No, all of them. Just remove partial class ARM64 and it's correct.
Cool. Sweet. This is why. Be careful what you have in your clipboard.
And then last issue for ARM intrinsics.
This one is fun.
So the class is DP, which is the flag name for dot product.
And it's parallel to advanced SIMD, right?
It would inherit from advanced SIMD, I believe.
But it's a top level type, basically. Yeah.
Yeah. And then the types are as given here. So the first operand is the addend, then the left, and then the right.
I just want to note here that, like, as you can see, the left and right are vector 64 of bytes, and the result of vector 64 of int. So we do dot product on 4x4 basis. We take first 4 and the left one, first 4 and the second one. We do dot product and so result in the first or zeros component of addend. And we continue for the second 4 elements in each. Like, is it clear from the signature what is gonna happen here, or you can say left quadruples or left fourths?
I mean, clear is a very relative term here. To me, it starts with the fact that I'm not entirely sure what a quadruplet is. Is that just 4 values?
Yeah. Basically, like, the reason why we need to add by selected something, either quadruplet or some other name, because right index parameter can take values between 0 and 2 exclusive in this case. So we can take left and multiply by first 4 of right elements or by second 4 of right elements. So we need somehow to specify that we can select on only 4 elements, not individual ones.
So basically, the operation is always performed on 4 elements, and you basically just select the start index of the first element, and then the operation takes the next 4.
Yeah, but you only can take, like, the value or the index is based on assumption that you're selecting 4 elements. So basically, like, if it's going to be byte offset, then it will be 0 or 32 or 64.
Right.
But since we specifying first element index, it's actually not first element index. It's a 8-bit 4 element index.
Sorry, you lost me there. Like, what does that mean? Like, you're basically saying. So I thought what you do is you basically say, well, the operation takes 4 elements, and right scaled index is basically the first one, and then the subsequent next 3 items are also used. That's how I read it.
Yeah, but you can't select first, second, third, and fourth. You only can select zeros, first, second, third, or fourth, fifth, sixth, and seventh, and so on.
Yeah, because because that's just the maximum size of the vector is just basically -4, right? That's the highest number you can select. So you can't select arbitrary 4 elements. You have to select consecutive, right?
Yeah. Your first element can be only at 4 on the position that is multiplication of 4 and some integer. Yeah.
Right. I mean that kind of falls out though. I mean that seems fine.
But I wasn't sure, like when I was proposing, what should be appropriate name for those four. Like, is it quadruplet or quadruple or quad or foursome?
Yeah, I mean, they all would work for me. I mean, like, as long as you have quad in the name, it kind of implies it's 4. I think I can get behind that.
Maybe I should explicitly say by selected 4 bytes.
It's not 4 bytes though, right? Or is it? I guess it's always 4 bytes.
Yeah, because it's operating byte.
Right.
4 bytes actually shorter.
I mean, the question is what happens when you have to support something that doesn't take bytes. Then we are back to square one, right? Then we have to pick a different name.
Well, based on this spec, I see that they added new instruction, which is dot product of mixed sign operands, and they still operate on bytes.
Yeah, if they never support something like an int16, then that's fine. I just try to avoid a naming convention where we corner ourselves. That's what we just said with reverse element index, right? Or with reverse element bytes. So if we believe they will only ever support bytes, then saying by selected 4 bytes is fine. But if you then have to ever support something else, then, well, what do we call this?
Yeah, I can guarantee this personally.
I don't have a suggestion for a better name.
Maybe by selected 4 elements.
I mean, 4 elements seems fine. That seems
Forple.
Forple.
Purple.
Okay, Forple it is. I like it.
I think quadruple is the actual better name there. You've got double, triple, quadruple, and so quadruplet makes sense in that sense.
Yeah, I was
And
gonna say
it's better than forple.
I wouldn't use just quadruple because we just added half. I'm sure at some point we'll add the double floating point. So at which point it now becomes a misnamed type.
Well, the official name for that is quad.
Oh, okay. Half, single, double, quad.
Yep.
Fair enough. Yeah, I think quadruplet is fine. I actually don't think 4PLE is a terrible name, but it's not very .NET-y, so maybe I do. Yeah, I don't know that this thing can have a good name because it, yeah. I mean, that's true for a bunch of these SIMD things, right? It's like you really absolutely need to know why you want to do it when you do it, because it's weird. They're all weird. Anyway.
That is all of, at least as far as I know, all of the ARM intrinsics now reviewed. At least for everything we're exposing for .NET 5.
About I have one more question, like the right scaled index, why do we say scaled? Scaled is just it needs to be at the boundaries of 4, is that the idea?
I believe that's the case.
Yes, I guess Tamar suggested this.
Yeah, I don't feel strongly. To me, it just seems more confusing than just right index. But
Yeah, I think with the term quadruple, just right index is probably enough, but scaled index does provide just a little bit of clarity that, like, that you can't do 0, 1 through like 16. It has to be 0, 1, 2, or 3.
Yep, then let's leave it as is.
But do we need T at the end of quadruplet? Like should be just quadruple?
Well, that's what Jeremy just talked about, right? Like it seems like it would be confusing to leave it off. Also, we just save one character one way or the other, so it's it's not really doing much for us. All right, so if that's it, then I will call it for today.
Yeah, unless you want to approve my spanifying certificates.
Okay, we have 4 minutes left. Let's do it. Which one is that?
38348.
You monster, this is like 4 pages worth of APIs.
Yeah, so I sent an email. There's no logical, there's no thinking here. It's take everything that took a byte array that was already making defensive copies and add a read-only span overload.
I see. So they would just forward to the other one and you would still do a defensive copy, but that's fine.
Yeah. I mean, it's actually it ends up being the other way, and so the array clone just becomes span to array. But yeah.
Sure. But either way, you just avoid the double copy, right? That's basically the idea.
Yeah.
Gotcha.
There's only one mild piece of thinking, which is in Certificate 2 collection. Yeah. So, oh no, we're not the collection yet. Yeah. So, in single certificates, there were 1, 2, and 3 parameter overloads. In the collection, there's only a 1 and a 3. So when I added the new one, I made the third parameter defaulted, and then I added the default parameter to the existing one. So there's bytes password, and byte password and flags on certificates, but on collections it's just bytes and then byte password flags. So I'm making flags optional here, so it looks like certs.
I see. So basically just make 2 changes. You add an overload and you also make the existing one optional. Yeah, that seems fine. Yeah, unless somebody has a problem with that, I can live with that. Seems pretty straightforward. Jesus.
Yeah, that's why I thought I could shove it in 4 minutes.
If you're feeling lucky, there's also another issue, which is really small, that I got pinged by a community member asking if we could review. It's 36105. Basically, for system drawing, you can get significant perf increase if we just exposed CachedBitmap, which exists in the GD Plus API, basically as shown here.
Do we need Marshall by ref object?
That I'm not sure. That's probably something I would ask Jan and Aaron about. If it's not needed, then I would suggest we drop it. The rest of System Drawing does have it, which is why it was put here for parity.
Is CachedBitmap an existing API or just an internal API?
It's it's existing in the C++ GDI Plus implementation. It's not exposed in managed.
So it's not, yeah. So like basically, the only reason why we would have Marshall by ref object is, let's say the API existed in full framework, then we should just match its shape. But like if it's a net new API, then I would not expose more stuff with Marshall by ref object if we can help it.
Sounds good to me.
Is there an explanation for why someone gave it a thumbs down?
Not really. I
No,
guess.
they did not. They did not comment.
Some people just don't like APIs. So what does the CachedBitmap actually do?
It's just a it's a bitmap that is cached.
Yeah.
Basically, the image is converted to the target format once, and then it's cached as the target format, so you don't have to reconvert it every time. And as shown with the implementation provided by the community member that also proposed this, it can provide a nearly 5 times perf increase by removing the need to keep reconverting to the target format.
Yeah, assume this is the same as JSON encoded text and what we just added for the SSL stream certificate context. It's the, you gave me a thing, I validated it, you're holding on to the validated or normalized state, and just give that to me over and over again. So I don't need to keep asking if your input is sane.
Yeah, I mean, that makes sense. I mean, the only concern I have is, like, are there any other cases where we accept bitmaps today where we should also accept a cached bitmap? Because if that's the only thing, then that's fine. But if it's all over the place, then you effectively create some debt where you now have to replump the same type to like 100 places.
So System.Drawing is largely a mirror of the GDI plus C++ API. Much like WinForms is actually a mirror of MFC in many ways. And so I don't think we'd be exposing cached bitmaps anywhere that the C++ implementation doesn't itself.
Right, and so so I take it then that the C++ implementation also only has it on basically whatever the device context equivalent is.
Yes, as far as I know.
Yeah, then that's fine. I mean, that's the only reason why I can see a thumbs down, right? Because you could say, well, just make just make the caching thing part of the bitmap itself, so you don't have to replumb the world. But if that's the only receiver, then that's fine. I mean, that's usually the problem when you have these types, right? Because now, like, if you replace one exchange type with another one, like, string and UTF-8 string or something, then that's just super painful, right? But if it's only one place where you sync it in, then that seems totally fair.
Yeah, that's at least all that I see with a search of the header, and that's documented on the actual docs page for the C++ version.
Then I think that's fine too. Okay, then let's approve this one here as well, and then move on.
Productive 4 minutes.
I think it's fair to say that's probably the most APIs ever approved in 4 minutes.
That might be true. Alrighty, then I wish you guys a nice day, and then we see each other tomorrow again.
Yep.
Bye bye, online people.